Yes, can everyone please settle down? Can you stop talking, please? I'm again repeating the instructions. Tomorrow we'll close the door at 11:08. If you're later than 11:08, you'll have to miss the class. No excuses. Please be here by 11:08. Okay, so this is the histogram of, yes, everyone please. This is the histogram for the quiz. Okay, this is the histogram for the quiz or the worksheet held yesterday. There are some people who got it well, but majority of the people are having something between 6.5 and 10.5. Some people didn't score very well. You'll definitely need to improve now. Right? For those of you who have not scored well, even though you have a best of 6 out of 8, please close the door. Start. While we have a best 6 out of 8, we should still not be waiting to score good marks. Right? As such, it's a very short course. The second announcement is that Monday is a holiday, all of you would know, and would be happy. But we've also already discussed that Saturday is a working, we'll have some extra sessions on Saturday just to compensate and ensure that we can finish the syllabus on time. Saturday morning, we'll have a class. Saturday afternoon, evening, we'll have the second worksheet. As you already know, there are 2 worksheets in a week, approximately 2 in a week. Some weeks maybe we'll even have 3. But this week we'll have the next worksheet on Saturday. Saturday morning lecture, Saturday afternoon, evening worksheet. As you would have already seen that very often what we discuss in the lecture does translate to questions in the worksheet. Okay, any burning question? Anything that you want to ask? You will probably get them today or tomorrow. We're still working out on an optimum algorithm to distribute the marks, which leads to least amount of chaos. So we'll have to see how to do that. We're looking at different possible algorithms to do that. Yes, other questions? Yes. Today's lab questions will be released before 2 p.m. Right. So for today's lab, there are 3 things which I'll want you to do. First, if you've not finished the previous lab questions, solve them. Take help from the teaching assistants, the staff. Second, if you need some hints on the assignments, not answers, the TAs will not be spoon feeding you. That's only to give you some hint to get started. They can potentially help you debug your program. Right? Third, after this, you should be solving today's questions. So that's how the today's and tomorrow's labs will go. Okay, some people are again coming late. So I'm just repeating the instruction. Tomorrow onwards, the doors will be closed at 11:08. If you're late, you'll miss the class. Yes. Not yet. So often the goal is not to sound very smart or to write code which is really short. Sometimes it makes sense to write shorter code because lesser the amount of code that you write, lesser the mistakes you make. But often there's a balance. You can make a very complicated looking program and even you will not be able to understand what you wrote in the program after some time. So that's the balance. So this is the histogram of the marks, right? Very often in the course, the different courses that I teach, we send the marks to the students via an email, right? So you should be expecting to get your marks after tomorrow or whenever they're distributed. So periodically we'll be sending you your marks up till that point of time. So the way we end up sending those marks is something like this. So let's say we'll have a sheet. We'll have the sheet as maybe name, and maybe this is quiz 1 out of 6. This is, let's say, quiz 2. So let's forget about quiz 1. And so I'll also have another column. What column should I have to be able to send you emails? Your email. So add column before email. Let's say that we don't care about roll numbers for now. So this is, let's say, alpha at iitgn.ac.in. Let's say out of 6, the marks is 5. So similarly, you will have some other, so on and so forth, right? So let's say we have 340 odd such entries. Now, how do I send such an email? I can invoke another Python library. So library is something similar to SMTPlib or other libraries, which can help me compose emails and send them via Gmail. So we can use, we can use the API, we can log in. So there are various ways in which you can do, again, not going into the details, but just think of it as, in order to send an email, you need to know the content of the email, right? That's the body of the email. Second, you need to know the subject of the email. Third, you need to know the person to whom you're sending, 2 fields. And in the body of the email, we'll say that quiz 1 is, quiz 1 out of 6, you've got 5 marks. Quiz 2 out of 6, you've got 4 marks. Right? That would be the body of the email. The email would go in the 2 field. The name will be sent something like dear first name, comma last name. This is an email. This email tells you about your marks in the EF 112 course. Right? So we'll have something like that. So let's say if we were to do this manually, how would we do that? We'll have a person, we'll have someone from the teaching staff sit. They will write an email. They'll open their Gmail Compose window, copy this entry, put it in the Compose window, copy this in the 2 entry, copy the marks, and they'll have to do this 340 odd times. Right? Is it efficient? Will you want to get such a job? No, right? So clearly there has to be a better way to do that. Now let's assume that we have a way of sending one data row, right? So we can send this alpha at iitgn.ac.in. The name is alpha, the quiz marks is this. We can automate this process and we can send one record, right? Now, how do we send multiple records? So we'll have to repeat the same procedure. The only thing which will change is the row number. The row number is 1, 2, 3, 4. So think of it as my algorithm for sending out emails would be retrieve row number 2, send out the email. Retrieve row number 3, send out an email. Retrieve row number 4, send out the email. And then we'll go till row number 340. Right? Does that procedure make sense? Right. So this whole paradigm or this way of thinking or way of solving problems is known as using loops. Right? All of us would have heard about the term loop somewhere. Outside of programming, where do you use the word loop? Loopholes, okay. What else? Where have you heard the term loops? Yes. Spotify play on a loop. You want to have a certain list of songs, 1 through n, whatever number. And after all the songs have elapsed, you again go back to the start. That is known as a loop. Who of you are caught in a habit loop of sleeping late and waking up late and then running to the first class after missing your breakfast? This is also a loop, habit loop, right? So all of us have different kinds of, we all have different kinds of loops. So loop means that there is some repeated amount of process, repeated operations, right? So while we're talking about creating such an email, let me show you examples of where people have made blunders trying to send such an email. So this is an email which someone was trying to automate. They were trying to similarly have a spreadsheet, and let's say they were trying to send to 5,000, 50,000, 1 million people. What does the subject say? This is a personalization test. First name, something, something. Hi, first name, auto, first name, old friend, something like that. So the name of the person should have appeared here, but instead the field name is coming, right? So this is not very different from when we try to print. So when I ask you the question of print first name, comma, last name, instead of printing the name of the person, you end up printing hello, first name, last name. Not very different from that. So it's the same bug, but this bug is now happening in production. There's another example. Hi, first name. Right. So I have personally received such emails from some big companies also. And then immediately, unfortunately, they'll have to quickly send another email which corrects these mistakes. So this was to show you the possibilities of automation using Python or programming. You can start with a spreadsheet. We do this in all our courses. We start with a spreadsheet, which we update, and then we automatically send out your marks rather than having to. So what is the problem in putting the marks? Why not just make the spreadsheet public? Isn't that easier? Why don't we do that? I don't want to, I don't want anyone to know my marks, right? And I don't want the students to know each other's marks. Unnecessary. I don't want to create any issues or such things. So it's better to send a personalized message with the specific marks. And since we've automated this, we can send this at any point of time. We do quiz 2, we can again send this. Okay. So when we're talking about loops or when we're talking about doing repeated operations, let's just start with an example rather than having to go with all the syntax, etc. So let's say I want to now write a program to print out the first n number, right? Print out the first n number, first n natural numbers. So I can write a number, I can write a program which would be something like, yes, print 1, print 2, print 3, print 4, print 5. Let's say, right. So let's say we wanted to print first 5 natural numbers. Is this a good method? Why not? I have repeated the code multiple times. Is this the same problem as sending out an individual email, right? The other problem here is that, let's say if I have to take an input from n from the user. So before I've taken the input from the user, I don't know how many natural numbers to print. In such cases, can I write out a program? How? Without using a loop, that's the question. So if we don't use concepts such as loops, so if I have, can you modify this program without using any additional terms which you've studied, which you have not studied? Commas and? Commas and? Slash n just gives you a new line. That's not the question. The question is that if I take n from the user as an input, I want to print 1, 2, 3 till n. Using this method, can I write that? You can't. Because in this method, we are fixing the program. We need to know beforehand the number of times you have to print. So again, you're using things which you have not taught. The question was using whatever we have studied till now. You cannot print out the first n natural numbers. So we've seen a common pattern. Another thing is, let's say that we made a mistake. We didn't want to print 1 through 5. We didn't want to print first n natural numbers. But the question was to print first n non-negative numbers. What should I then do in this program? So modify each of them now. Right? I've had to modify 5 lines to make one small change. Right? Let's say if I had to modify this program, I asked you to change this program. Instead of using printing 0, I want to be printing 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, things like that. How do I then modify this program? So you'll have to then add to a string. You'll have to check the length of that number, whether it's 1 digit, 2 digits, convert to a string, right? So all of this is very manual process, very time consuming, very error prone process. Rather, we should be looking at ways to automate things. That's where we come into this concept of loops, right? So I'll first write the program and then we'll go over the syntax for this. So let's say that n is equal to 5. My number is equal to 1. My number is less than equal to . So this is a small program that I've written. The output seems to be correct. So we wanted to print the first n is equal to 5 natural numbers. I have written this program. If you notice that there are few important things in this program. One, I need to initialize some variable. right? I've initialized the variable num equal to 1. So you should think about initialization as the place where you want to start printing out, or where you want to start doing some operations in your program. So since we wanted to print out the first n natural numbers, it makes sense to start from num equal to 1, right? So then we have this while num less than equal to n. Does this line remind you of a line you've already seen earlier? If, right? So previously we written a program if num is less than 10, so print number is less than 10 or number is greater than 10. We had written programs like that. Fairly similar. Instead of an if, we have a while. And we'll come back to what this while means. But for now, let's just assume that this is checking some conditions on a repeated basis. Then we have print num, nothing new. So you already know how to print nums. Then we have an interesting line doing num equal to num plus 1. So we start with num equal to 1. We print 1. We increase num to 2, print 2. We print 3. We increase, so we start with, let's just go slowly. Start with num equal to 1, print 1, increase 1 to 2. So those who are coming in late, we'll be closing the doors tomorrow at 11:08. Please do come on time. If you miss and if the doors are closed, you'll have to miss the class. Num equal to num plus 1. So then num becomes 2. So another way to look at this is we can just run this program through the Python tutor to help you just understand the debugging around this. Okay. So we start with n equal to 5. That variable is just created in memory. Num equal to 1, we create another variable num whose value is 1. While num less than equal to n. So think of while num less than equal to n as checking the condition. So first it checks the condition. Is num less than equal to n? What is the value of num? Num is 1. Is it less than equal to 5? Yes. So the condition is true. It enters into this block of code, into this indented block of code. It then prints out num. So if you see in the output now, you'll see that num will get printed. It prints out 1. Num is then increased to num plus 1. So previously num was 1, now num is increased to 2. Now interestingly, when we were writing an if conditional, once we executed that indented block of code, we exited and we went forward in our program. But now if you see the red line, the red pointer has gone back to line number 4. So this is the difference between if condition and a while loop. In the while loop, you keep checking, you keep running the indentation, the indented block of code till the time the condition is true. Right? If the condition is true, enter into the indented block, then go back and check the condition again. So that is the key construct of the while loop, and that's the difference between the while loop and just an if conditional. So now we've gone back and checking the condition. Now num is 2. Is 2 less than equal to n? Yes. So then again enters into this conditional block, into this indented block, prints out num. So 2 is printed. Now num is increased to 3. Num equal to num plus 1. Num now becomes 3. So the edit happens here. Again goes back to the condition checking. If num less than equal to n, is 3 less than equal to 5? Yes. Again goes into line number 5 and 6. Prints out num. So prints out 3. Num equal to num plus 1. Now num becomes 4. Again goes back to line number 4, checks the condition. Is the condition 4 less than 5 equal to 5 true? Yes. Prints num, prints out 4, increases num to num plus 1, which becomes 5. Again goes back to line number 4. Is 5 less than equal to 5? Yes. 5 less than equal to 5. I think you were confusing it with 5 less than 5. 5 less than equal to 5, yes. Prints out num, prints out 5. Num now becomes 5 plus 1, which is 6. So goes back to line number 4. Is 6 less than equal to 5? No. It exits out of this conditional block of this loop. So that's how this code will execute. And at this point of time, the code stops. Right? So Just to understand this even better, let's just copy paste this code and visualize the flow chart for it. Right, so this is the flow chart. N was 5, num was initialized to 1, right? And I've just modified it on purpose. So this was earlier showing while. I've purposefully just written it if instead of a while, just to make you understand that in the while loop as well as in the if conditional, the checking is the same. But it's just that we first check here, is num less than equal to n? Yes. You print num, and then you increment num, and then again you go back to this point. From num equal to num plus 1, you go back to this point, and you then again check if num less than equal to n or not. So basically the false branch, the no branch from this just exits the program. So let me just actually write that so that it's easier for you to also relate it. Right? So this, in my opinion, is a slightly easier program to understand. It's not slightly modified program, but it's probably easier to understand. Start with n equal to 5. Num was initialized to 1. So I'm again using the word initialize. So the first value I'm setting to num. I'm constantly modifying the value of num. So therefore, when we're modifying the values of something, we need to give some initial values. Right? The first value of num that I'm giving is 1. I check whether num is less than equal to n. If it's not less than equal to n, I just print done. I don't enter into the loop. If the num value is less than equal to n, I print num, increase num, go back and check till the time num becomes greater than n. And then I just fall out of the loop and I just print whatever is after this statement. Yes. Which part? Can we get the mic to the phone? Just one sec, one at a time. They're getting the mic. Print done. So if the condition is false, right? So if num is greater than n, right? So let's say if num was 10, right? So if num is 10, is num less than equal to n? No. So if n is 5, if num was 10, is 10 less than equal to 5? No. So this condition is false. It does not enter into this indented block of code, and it directly goes to the lines of code after that, after the condition checking, or in the flow chart. When num is greater than n, right, it just goes and prints done. It does not. So from this conditional checking, from this diagonal block that you see, there are only two options, either yes or no. If num is greater than n, then you take this branch no and print done. If num is less than equal to n, you take this branch which is following yes, you do some operations which is print num, increment num, go back to checking the condition. Does that answer your question? Yes, other questions? If you don't initialize, what will be the output? So what do you want the program to be? So do you want the program to be, do you want me to delete num? Is this the program? Yeah, so if I don't initialize num, then what value do you want? So you don't want to give any value to num, is that the question? So if you don't give any value to num, then num is not declared. At this point of time, you have not declared num, you cannot be using that variable. So the computer at this point of time does not know what is num. Right? So if you have to use num, you have to define its value. You have to initialize its value. Yes. How will I do that? So I can just give you a hint for that. Just use something known as F strings, F hyphen strings, formatted strings. Why do you want to do initialization in while? So, okay, so let's answer this question. So the question is, we do an initialization like this, right? Now let's see what happens. Is this what you're saying? No. So if you're coming from a C, C++ background, then this explains it out. Are you coming from C, C++ background? Okay. So you'll have to throw away your C, C++ background for the remaining 3 weeks, and you have to just explicitly define the values there. So even in C, C++ background, that's equivalent to just declaring the variable earlier and defining its value earlier. Yes, other questions? Yes. Just 1 second. We're getting the mic.
Can you explain the difference between that while and if once again?
Okay. So let's just delete this. Let's just have the same program, num equal to 1. So this is the program with while, and this is the program with if. Right. So let's just compare the output of these two programs. Right. Everything is same in the program, except for the fact that here we have while num less than equal to n, and here we have if num less than equal to n. So let's first run this if one. Start with n equal to 5, num equal to 1. Is 1 less than equal to 5? Yes? 1 less than equal to 5? Print num equal to num plus 1. Exit out of this if conditional block. That is what happens in this. So, done with it. So the main difference will be in the question of the loop. Do we go back to some set of statements or not? Do we go back to the condition checking or not? That is the difference between while and an if. Right. So these are the two programs. So this prints 1, 2, 3, 4, 5 done with while. This will print just 1 and done with if. But to understand this even better, let's just create another flowchart for this. Can the TAs ask the classroom support team if they can just turn on the air conditioner at 26, 27 Celsius for just a few minutes? It's getting a bit warm. We'll have to figure out the classroom support team either from here or block 7. Are students also feeling a bit warm? Do any of the TAs know where to go? Block 7. If for some reason this is not giving us the correct flowchart, I think. No, this is indeed the correct flowchart. There's no problem in this flowchart. So in the yes, into the flowchart. Okay. So the code is the same as I'd written in the Jupyter notebook. This is the code. Everything else is the same. I've just replaced the while with an if. And the corresponding flowchart looks something like the following. Start with n equal to 5. num is equal to 1, you check if num is less than equal to n or not. Right? If it is not, if num is greater than 10, just say that you're done with it. You're finished. You don't enter into this set of lines. You don't enter into this indented block. Right? But if num is indeed less than equal to n, which means that the branch gives you answer yes, you print num, increment num, and after that, you still just exit out of this conditional block and you print done with it. Yes. Two will be stored inside num. The value of num is 2, but you have printed 1. And you're done with this program, you're done with the conditional block. Yes, because we have incremented the value of num to 2. But that's all there is in this program. This checks the condition only once. So that is the difference between if and while. If checks the condition only once, while keeps checking the condition till the time the condition is true. Right? So if you see, if check the condition once, it would have either been a yes or a no. It has different paths for yes or no. In the yes path, it executes a set of statements. In the no path, it executes some set of statements. But there is no looping back to checking the condition again. Right? Does everyone follow? No looping back to checking the condition again. In contrast, if we had the other program, let me just save this also. In contrast, if we had the other program, which was with the while, right? So I'll just change the while to an is, just to make it. So the is the same condition which we had in the previous case. The condition checking is the same. The only difference is here we start with n equal to 5, num equal to 1. You check num is less than equal to n. Till this point, it's the same. But the only difference becomes that after executed the statements which are a part of the yes branch of code, you go back again and check the condition. Right? Let me do one thing. Let me just open them side by side. Okay, no luck. I can just open another instance of this. Anyway, if we go back to this program, is the difference between if and while becoming clear now? Yes. So the main thing is while checks the condition till the time the condition is true, keeps checking the condition. It is a loop. So loop means it has to go back to the checking of the condition. Once it's executed everything within the indented block. If will check the condition only once, and depending on the condition, it will either enter the indented block or not enter the indented block. Yes. Other questions in this? Yes. Any other question in while? That's what. So we then look at a general structure of what we'd want in a while loop. It might look something like the following. You initialize something known as the looping variable, right? In the previous case, the variable num was the looping variable. I'm calling the looping variable as the variable which is getting modified inside of the loop, right? While condition on the looping variable. So you want some condition because you're changing you're modifying the looping variable. You'll want the condition to be some function of the looping variable. May not be an immediate function, but some function of the looping variable. So then do something useful, then change the looping variable, then do something, right? So if we come back to our code for printing the first n numbers. So let's just try and write this program under this paradigm. Init the looping variable num to 1, check the condition which depends on looping variable, right? So the condition is num less than equal to n. Does the condition depend on the looping variable? Yes. Then do something useful. Modify the value of the looping variable. Right here we have incremented by 1. In some other program we could have done something else. And while we are ending here, we could have done something else also. Right. So if you understand this paradigm, you should be able to solve all questions related to loops. And if there's only one concept, let's say if there's one concept I definitely want all of you to pick up from this course, it's loops. Maybe there are other concepts which we'll teach, but if there's a single concept I ever to pick, which you should definitely learn, as loops. Is there a question? Can we have the mic there?
Sir, what if we doesn't modify the value of num, or if we just write num is equal to num plus 0?
Okay. Okay. So let's say that if we don't modify the value of num, so this is entering into potentially dangerous territories of something known as infinite loop. Does anyone have heard the term infinite loop outside of the context of programming? Sorry, Avengers? Anywhere else you have heard the term, or name of a place, or name of some factory, name of some office, infinite loop? Okay, let's just check. I wonder if it's the name of some. One infinite loop, Cupertino, these Apple's, this is the address for Apple campus. Okay, so coming back to the question, what if we forget to modify the value of the variable? So let's just run the same program. I would rather run such a program in Replit. Why do you think I'm running this program in Replit when I've been running everything on my local system? So I am careful about not hanging up my system and disturbing this flow of this class. So let me just create something in Python and let me say loop infinite. So the program will be exactly the same. The only difference would be in terms of the fact that I'm not modifying the variable correctly. N is equal to 5, num equal to 1, while num less than equal to n, print num. So just to help you appreciate what is happening, I'll slow down things a little. You don't need to know this, but I'm just doing this so that you can appreciate what is happening. So now you're saying that we don't modify the variable. We go to shell. It's already exceeded 5 times, which was the case previously. And we're seeing two numbers. The second one is always a 1. The first one is some weird largest number. So it says that I've written something known as time.time. Does anyone know what this returns? The number of seconds, milliseconds, I don't know whether the unit is seconds or milliseconds, since 1st January 1970. Right? So if you see that, you'll see a difference of almost 1 second between each of these, 1 unit between each of these. So this is showing you that the time is definitely running. This program is definitely running, but it's never going to end, right? And if we look at the flowchart of such a program, that will also clarify to you. So in fact, we don't even need to look at the flowchart. So if we looked at the flowchart of any of the program right? So this is a program, right? If we forget about num equal to num plus 1, or let's say that if we had done num equal to num plus 0, right? It's the same. So I don't want to modify the program. That's why I'm showing this. So the first time the condition is met, right? You print num is not changed. If the first time the condition was met, you've not modified num, will the condition be true the second time, the third time, the 1,000th time, the millionth time, right? So this is known as an infinite loop. This is one of the common mistakes which students often make. So if you make something like an infinite loop, what should you be doing then? If you've made a mistake, you have made an infinite loop program, what should you be doing? Sorry? Should you pick up your laptop and break it? Is that what you mean? Then stop the program. How do you stop the program? By closing the window. Do you mean closing windows or closing the window in which you're running Replit? Delete the shell? Okay, what could be some other ways? Has anyone heard of interrupting? The program stopped for me. What did I do? Control Z, Control C, depending on the OS, the shell that you're working in. The program fortunately stopped for us. Right? We're able to make an external interrupt to the program. So in this case, it's Control Z, right, which I wrote to stop this program. But coming back, we should be always very careful in while loops following this paradigm. Initialize the looping variable while the condition which depends on the looping variable. Do something, then change the looping variable, then do something if needed. Right? So inevitably, you'll always want to change the looping variable. That's the whole concept, the point of the looping variable. There could be some corner cases where you keep modifying the condition or you keep modifying the input itself. But let's not get into those cases, corner cases. For now, let's assume that we have to modify the looping variable in most of the programs that we're writing, at least in today's and tomorrow's lecture. Other questions on while, if, on looping? Okay. If not, then let's write a slightly advanced variant of this program. So previously we had printed all natural numbers from 1 through capital N, through N, right? Now let's print out all odd numbers, right? So let's print out odd numbers from 1, 3 till N. So the way we'll do this is, again, we'll say that N equal to whatever we want, odd numbers till 10. Is 10 an odd number? No. So then we need to write my num equal to 1. First, let me just simplify this for you. First, let me just take this case. While num less than equal to n, print num equal to num plus 2, right? We started with 1. We know that's the first odd natural number. So 1 plus 2 plus 2, again, we keep doing that. Thus, this is the program we'll need. Instead of incrementing by 1, we're incrementing by 2. We run this program, we get 1, 3, 5, 7, 9, 11, which is the expected answer. So we have written it in this way. We could have also written this in a slightly different way. Let's say that we always increment by 1 only, right? So if we increment by 1, then our numbers, the value that num will take will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But we don't want to be printing all these numbers. What numbers do we want to print? Odd numbers. What is the special property of odd numbers? Or how do we figure out if a number is odd or even? Modulus. So only if the number is divisible by 2, we want to print it. So we modify this program slightly. If num mod 2 equal to 0, print num, and irrespective of whether the number is even or odd, we want to increment num by 1. Right. This program should give you the, okay, sorry. This program gives you, so we were looking at odd numbers, therefore num mod 2, whenever it's equal to 1, we print that num. Right? So there are two ways in which you could have done this. Which of these two looks more efficient to you? First one, why? You don't have to write that if. So in the first case, we are directly going to be looking at approximately n by 2, right? N by 2 or n by 2 minus 1 number, right? Or n minus 1 by 2 numbers, right? So in the second case, we have to consider all the n numbers. Additionally, we have to check is a number divisible by exactly divisible by 2 or not. So that check we'll have to do on all the n numbers. Right? So it's redundant code. That's where if you have a better logic, that can always be it if you want to be simplest solution very time. So if n was very large, then the first program would be fairly quick compared to the second one. Okay, questions? Okay, let's. If you don't write num equal to num plus 1, then in this program, then num, the initial value of num was 1, right? If num modulus 2 is 1, modulus 2 equal to 1, yes. Print num, print 1. So it prints out 1. Then you go back to the condition checking in the while loop. What is the value of num? 1, because you have not modified it. If num less than equal to 1, yes. Is num modulus 2 equal to 1, yes. Print num, the value of num is 1. 1, 1, 1, 1, 1, 1. So it's an infinite loop. Yes, other questions? Okay, so now let's write a small modification of this program. We want to print numbers like 1, 2, 4, 8, 16, 32. And I don't want to be printing them in a new line. Right? I want to be printing them with, let's say, space in between. How do I write such a program? What do you understand by this sequence? To the power n, right? So then let's write this program. Again, so why don't you think about this program and just write this in your notebook? Just take 2 minutes and try to write this in your program, in your notebook. We can also take a break of 5 minutes if you want, but please be back by 12:05. Sharp at 12:05 we'll start. If you want to sit and work through this, you can still work through this. Okay, so let's get back and try to write the program. Was anyone able to write this program? Okay, everyone, please. You've had your break now. Let's get back to the class. Yes, can we keep the discussions to later, please? Okay. So we're trying to print 1, 2, 4, 8, 16, 32 to the power n. So again, our n is, let's say, 5. Our num is 0. Why do I have num starting from 0? So the first number which I'm printing is 2 to the power 0, which is 1, right? While num less than equal to n. Yes, everyone, please. You can do your discussions later. While num less than equal to n, what do we want to print? Two to the power num, but I don't want to be ending with a new line. So I'll give it n equal to space, right? This means that when this line is printed, after it, the last thing which is printed is the space. The next print will start from that point of that position instead of starting from a new line. If I find this program here, is it correct? So we have done something useful. So again, it's useful to initially when you're writing out, just write out the comment. So just follow this template. Right, just follow this template. Initialize the looping variable, check the condition, do something. So initialize the looping variable to, so such comments are always useful. Initialize the looping variable num to 0 as 2 to the power 0 is 1, which is the first term. Right, then this is the condition, check condition. Then this is a print, and then we need to increment num, modify looping variable, num equal to num plus 1. That's it. Is this program correct? Am I missing anything? Try and see. 1, 2, 4, 8, 16, 32. Right? Any doubt in this? Any doubt or question? N is also variable. You can also take n from the user as an input. N can the no, end is not a variable. End is a special argument or a special input to the print function. No, you have to use end. End is a reserved keyword within the Python print function. So you should just look at the documentation. Whenever you get confused, look at print. So this is the documentation for print. So you given the values you want to print, you give a separator, which we saw yesterday. The separator is the string which is put between two things which you're trying to print. And that end is a string appended after the last value, default a new line. We didn't want the values to be printed on a new line. We instead wanted them printed on with the space in between. Right? Yes, other questions? Okay, so now let's modify this program a little. And again, let's do some exercises on your notebooks. Find out this, write a program to find the sum of first n natural numbers. So again, I want you to be looking at this pattern. This pattern. Initialize the looping variable, while condition, do something, change looping variable, do something. Right? Using this pattern, find the sum of first n natural numbers. By the way, it's a request to please not try and outsmart us. I see that the strength has dropped. You can tell your friends that if you keep doing these things, we'll also have to follow suit. We may then do a couple of attendance. We may do an attendance now, right? So please don't try and mess with us. Please don't play with such things. These classes are for you. Yes, is there a question? N should be an input. So if you just remember this pattern, this 4 or 5 lines of pseudocode, you should be able to write most programs very simply using the while loop. Okay, does everyone have an answer? Any questions? Anything you're finding difficult in this concept? So previously we were just printing out things, right? This is the main difference. Previously we just printed out things, but when I mentioned do something useful, when we're trying to find the sum, we'll have to do something different. Right? So for that, let me first write the program and then we'll see. So we'll call the sum of numbers seen till now. That's a horrible name that quite a big name that I've given, but that's actually what we're trying to do. Sum of numbers we've seen till now. N is equal to 5, right? Let's say this is the number which trying to find the sum of first n natural numbers still, while sum nat equal to 1. So n nat is now denoting the number of natural numbers, the natural number which we are currently considering. Natural number we're considering. This is the total numbers we are considering. This is the sum while nat less than equal to n, sum of nums seen till now equal to sum of sums till now plus nat So we have this program, right? This is not very different from what we've been seeing earlier, but there is a key distinction, and this is a very programmatic way of coming up with the sum of first and natural numbers. So we say that before we've started, the sum of first, so okay, so the easier way to understand this is, let's just run this with varying values of n. If our n was only 1, right, then the answer we get is 1. If our n was 2, our answer should be 1 plus 2, right, which becomes 3. And that way we are just incrementing the previous sum to, so if I have to ask you the question of what is the sum of first 4 natural numbers in terms of, let me write this. What is sum of first 4 natural numbers in terms of first 3 natural numbers? Okay, can you answer this question? What is the sum of first 4 natural numbers, which is 1 plus 2 plus 3 plus 4, in terms of the sum of first three natural numbers. Right? So what is the sum of, so can we say that sum of, let's say sum of first four natural numbers would have been 1 plus 2 plus 3 plus 4. Right? This is what you're trying to calculate if n was 4. But similarly, we could have defined an S3 to be sum of first three natural numbers. Right? If we have S3 defined, can we write S4 equal to S3 plus S4, S3 plus 4? Similarly, can we, if we had S2 defined plus 2, can we have written as S3 equal to S2 plus 3? Similarly, if we had S1 defined to be 1, we could have written this as S1 plus 2. And we could have then written S0 equal to 0 plus 1. Now, do you see why we have used the formula that we have used? You start off with the sum being 0, right? And then you add 1 to it, you add 2 to it, you add 3 to it, you add 4 to it. Finally, you get the sum of first four natural numbers. The difference between this program and the above program that I've written is, first, in the above program, I'm having a loop, right? Which will loop through 1, 2, 3, 4, and that's it. Actually, it's 5. N is equal to 5. Let me just make it 4, right? So S, the sum initialized. So if this variable is looking a little dangerous, let me just call it S. Right? S, the initial value of S is 0. Then you add the first natural number 1. You add the second natural number to it, to the previous sum. Add third natural number to the previous sum. Add four natural number to the previous sum. Right? We can also understand this via just copy pasting this in the Python tutor. Start with S equal to 0. Natural number we are currently considering is 1. N is equal to 4. Is nat less than equal to n? Nat is 1, n is 4. Is the condition true? Yes. S becomes S plus nat. So S becomes 1. At this stage, can we say that the S represents the sum of first 1 natural numbers? Yes. S becomes 1. Nat becomes 2. We do nat equal to nat plus 1. Again, is the condition true? Is nat less than equal to n? Yes. Now S becomes 1 plus 2. Right? At this stage, S becomes 3. Can we say that S is the sum of first two natural numbers? Right? At this stage, S is the sum of first two natural numbers. We run the next iteration. Nat becomes, from 2 it increments to 3. Again, the condition is true. 3 is less than equal to 4. Again, we run S equal to S plus nat. So we'll have 3 plus 3, which is 6. So 6 is the sum of first three natural numbers. We repeat this again. Finally, now nat will become 5. Right? Nat becomes 5. Is 5 less than equal to 4? No. So therefore, it does not enter into this conditional block. It exits out of it. It will then just print out the values. Okay, so this is, the variable should have been an S. This program will not correctly work. This should have been the program. So in this case, you'll get an error, but the answer will then come out to be the value of S, which is 10. Right? Any question in this? So throughout, when we're studying things like looping, we will be looking at the same pattern again and again, again and again, just with slight modifications. Previously, we were just printing out things. This time, we're doing some useful calculations. Right? For example, here the calculation is that we maintain a running sum of the numbers, natural numbers seen till that point. Yes. So often what helps is to just check what I'm doing with the facts which you know. So what is the formula for the sum of first and natural numbers? N into n plus 1 by 2. So I could have also just verified this with n into n plus 1 by 2. Is this the correct way to write? Why not? So this may do n into n and then 1 divided by 2, right? Which is wrong. So you wanted to do n into n plus 1 whole divided by 2, which also gives you the answer 10.0, but you could have just done flow division to get the answer as 10, which matches our answer here. Right? Another Python way you could have done, I don't recommend doing this right at this point of time because we have not done this yet. Range 1 till n with a space of 1. Sorry. We still get the same answer. The simplest way is to use this. Wherever possible, use a closed form expression, which you have. But since we're learning how to use loops, therefore we're looking at this kind of a method. Right? Any question in this? Yes. If the print statement, if you say that print was here, yes. So then the output, what would have been the output now? It would print the sum of first n. It would, for each iteration, it would print the sum seen till now. So it would print 1, 3, 6, 10. 1, 3, 6, 10. Right? This is also a useful program because now you're getting the running sum. Yes, other questions? So this is actually a good question. I was expecting people to ask why I have put the print outside the loop. Previously, the print was within the loop. Because now the useful thing which I want to print happens after I've done all the work. Previously, the useful thing which I wanted to print was a part of the loop itself. Right? Here, the useful thing is to print once I've included all the elements in the sum, then I print it out. Why have I not named the variable as sum? That would have been a better choice of variable, right? Sum is already known, is a keyword. Will that work or not? Should we just check? So first, it's highlighted in green, right? So will this work or not? Let's just try out. It works out, but it's highlighted in green. So sum is an inbuilt function in Python. You can rename inbuilt functions in Python. Don't do that. It's a very bad practice, right? So there are some functions like max, min, sum, etc. Don't rename them. Use other better variables. Yes, other questions? Any question? Okay, so then let's modify this program to find out n factorial. Can you take 1 minute, 1 or 2 minutes, modify the current program, take the input from the user n, and then print n factorial. Yes, do we have the program for finding n factorial? Does everyone remember the definition of n factorial? N factorial equal to 1 into 2 into dot 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 till n multiplied. right? So we don't need to modify this program much. We'll just so previously we were summing up things. Therefore, the sum was initialized to 0. This time we're finding the products of things. Should we be initializing that to 0 or 1? 1. Products, if you initialize to 0 and multiply things, you'll get a 0. I'll naturally call this number as a P instead of a S. So previously we were adding up things. Now we'll multiply things. Everything else remains the same. Start P with 1. Then define the natural number. The total numbers we're considering small n, while natural numbers is less than equal to n. P product of numbers seen thus far is P into natural number currently considered. So we run this program nat equal to nat plus 1, print P. 4 factorial is 24. 10 factorial is 362800. If I just want to verify this, I will use a inbuilt package. And I get the same answer. So I usually try to run different methods and just do a comparison that it's product. It naturally makes sense to name the variable in a slightly better fashion because F, I get the interpretation that for sum, P means for product, but you could have used any other variable. But I'm importantly initializing it to 1 instead of a 0 because now you have to do products of numbers seen thus far, right? So you'll have to repeat this procedure. P0 equal to 1, P1 equal to P1 into 1, P2 equal to P1 into 2, so on and so forth. That's how you get n factorial. Yes. So thus far, all clear. Any questions? Can I show this one in Python tutor? Okay. I'll show it now, but this is an exercise I would want all of you to do at your own time also later on. And then after you get sufficiently experienced, you should just try to do this on your own also using pen and paper to get more clarity. So start with P is initialized to 1, nat is initialized to 1, capital N is 10. Is nat less than equal to n? Yes. So is nat less than or equal to n? Yes. P is equal to P into nat. So P becomes 1 into 1. P becomes 1. Nat is incremented by 1. Nat becomes 2. Go back, check the condition. Is 2 less than or equal to 10? Yes. P equal to P into nat. So P becomes 1 into 2. Right? So it becomes 2. Nat is incremented to 3 and remains the same. Is 3 less than or equal to 10? Yes. P equal to P into nat. So 2 into 3, 6. 6 into 4 into 5 into 6 into 7 into 8 into 9 into 10. That's how it will happen. So therefore, it will become 6, 24, 120, 720, 5040, 40320, and 36280. Okay. Other questions? Okay, how can you minimally modify this program to give the output as 1 factorial equal to 1, 2 factorial equal to 2, 3 factorial equal to 3, till n factorial equal to n? How do you modify that? It's a really short change to this program. We'll move the prints within the loop itself. So then we'll do something like print. So I'm using some elementary operations here. I could have done this much better using f strings, which I will always recommend using. But since we've not yet studied that, so I'll say print p plus factorial equal to, sorry, nat factorial. So I have to write nat minus 1. Okay. Okay. Does this program make sense? 1 factorial equal to 1, 2 factorial equal to 2. Interestingly, I have written string of nat minus 1. Why not nat? Because we updated just before this. So if you wanted, you could have also written a slightly different program. and now just use. Right. So while I've written this very quickly, that's because I have years of practice. If you've not, if this is not becoming clear, you'll have to actually look at the difference between the two programs slowly and understand that where do I use NAT, where do I use NAT -1. Right, you'll have to actually walk this through pen and paper, do a simple dry run, and then you'll get the rationale behind using NAT or NAT -1 at different places. Questions on this? Okay. So I will actually just show how to write an F string also. We'll study this in detail later, but again, I think it's a fancy thing to do. Okay, so I have done some modification to the print, right? First, let's verify that this gives us the correct answer. Indeed, it does. And so that's the beauty of using something known as formatted strings. We are putting in the values of the variables directly within. We didn't have to use pluses. We didn't have to weirdly make complicated strings, concatenations, and other things. Just look at the syntax, it's appreciated. If you want, you can play around with this in the labs, but I'm not teaching it formally at this point of time. It's just a fun thing to. If you want to use, you can use this in your programs. Okay, so let's have another simple program. Try to find out the sum of first n odd numbers. Write a program to find the sum of first n odd numbers. First n odd numbers. Yes, do we already have the program? Has anyone been able to write? First n odd numbers. So you may get the answer directly, or you may use different tricks. So let's just first write the programmatic way. So again, s equal to 0, n equal to 1, first n odd numbers, right? So let me denote O as the odd number I'm considering. So I'll write different variants of this. And count equal to 0. So count currently, how many odd numbers have I seen? Count of odd numbers I have seen thus far. right? While count less than n, so the number of odd numbers I want to add, while count less than n, sum equal to, okay, we can just make it smarter. Is this the correct program? Is this okay? Is this correct or is this wrong? Okay, what is the mistake? Count equal to? Count is telling me the number of odd numbers I have seen. So count of has to be 1 through, sorry? For finding the sum of odd numbers, I firstly know that the sum of odd numbers is. So firstly, we can make this, write the program in this way and try and be a little smart, or let's figure out what is the odd number, right? What is the nth odd number, and then add that to sum, right? So let's say that my odd number, I'm starting with O. That is denoting the nth odd number. So my odd number which I'm considering is O plus 2. Each time I'm incrementing my odd number by 2, my S by O, my count by 1. Is this the correct program? Or is there something wrong again? Let's just run this and see. For the first 5 odd numbers, the sum is 25. For the first one, it's 1. So this is another thing which I usually recommend. Once you've written a program, run it through a few simple input output pairs, starting with the base condition, which is 1. If you get the wrong answer for n equal to 1, you'll get the wrong answer going forward also. For n equal to 2, you would have expected 4, which is 1 plus 3. But if you're confused at any point, you should always just say that you should just print out those variables. So print, I just use f string for now. Odd number currently that we're considering is O, and the sum till now is S. Odd number is 3 because we've already considered, right? So we consider odd number 3, sum till now is 4. Odd number which we get is 5, the sum till now is 4 plus 5, 9 plus 7, 16, 16 plus 9, 25, and finally to get the answer is 25. Right? Again, this may seem very simple when you're just looking through the code, but it's highly recommended that you walk through this code slowly. You try to write this code on your own. You will perhaps make some small mistakes. So there are some things which I'm just brushing under the carpet, but you'll have to notice them. So why have I used less than n here? Previously, I'd been using less than equal to n, right? The important thing is to be able to figure out that what is the condition that you want to execute, that you want to be true. In this case, it's actually count less than n. Any questions? If we interchange these two lines, no, there will be no change. Oh, okay. If you change these two lines, yes, there will be a difference. You will have to accordingly, so you can still get the program to work if you do S equal to S plus 1, O equal to O plus 2, but you have to modify the logic a little bit. That's where you can have multiple programs, multiple different ways of doing the same thing. I'm just showing one possible way, which is the way I was just thinking it through. No, you won't get an error because O is already defined as 1. the O is already defined, you won't get an error, you'll get a wrong answer. Error means that, so there are different kinds of error. You'll not get a syntax error, you'll get a wrong answer. Okay, any question? (12 plus 1 less than). So you can, yeah, you can just modify that to be smarter. You can just do it that way, and you can avoid using additional variables. You can do that. There are various ways, as I mentioned. Yeah, so you could have just looked at the fact that, so what some of you are trying to suggest is that there is a relationship between the nth odd number and the actual value of the nth odd number, right? So what is the first odd number? 1. What is the second odd number? 1 into 2 plus 1. What is the second odd number? Third odd number. So you can build up the 2n plus 1 like structure, relationship between them. So in that case, all you need to consider is the count variable, and the sum will have to be accordingly adjusted, right? So you should try this on your own. I will not show the answer at this point of time, but these are different approaches you could have used. The PDF for this notebook. So I'll try and upload this today afternoon, evening. Sorry, the previous ones is also not yet uploaded because I have to do some small processing on that. It will take some time. Okay, so let's do one last question, and after that we'll have your grades. I believe they've already done. They've already done with the sorting. So perhaps let's just do that question tomorrow. Let them discuss the distribute the sheets. So please be sober while they're distributing the sheets. They have followed the policy which we had shared. I had a recording. The recording was shared with them. So they have tried to check with the best intentions with the answers which I had given, right? And before you leave, you have to return the sheet back to them, right? Please don't try and play smart by trying to modify the answers now. So none of that is going to work for you. Please don't do that. In case you're caught doing any of that, or we sense you've done something wrong, you will, again, the institute policy is that you may be failed. So we have the labs from 2 p.m. onwards. The lab questions will be released in due course before that. And we'll have a lecture on Saturday, quiz on Saturday evening. Okay, thank you. Distributing the sheets. How are we distributing these? Section wise?
Okay. 5 sections and one for which students do not know the section they didn't mention on the sheet. So there are total 6 sections.
Okay.
So we probably have enough TAs. So each section we may have 2 TAs assigned to that. That is also a possibility. Otherwise, one by one. So in that particular bunch, we have to do linear search only.
Yeah, that's
yeah. And
so
for students who are doing like some editing and then they'll come. So what, like, do we even put some TAs for the?
No, so no editing would be considered. So if they say that this was not marked, nothing is considered. Okay. So we have done a do of this. Yeah. Okay, so we have different TAs corresponding to different sections. Section 1 TAs, can you just take your sheets and go to the leftmost corner? Do people in section 1 know them? Just catch hold of these 2 folks. Section 2. Okay. Yeah, and there are some students who have not mentioned their sections. You will have to either remember that you didn't mention your sections, or have to wait till everyone has got their answers. So 1, 2, 3, 4, 5. So the people who didn't mention this section, they can just move to this extreme. Everyone should be returning the sheets before they leave this room.